Hi class. Thanks for being willing to watch these videos considering we had snow days and couldn't meet all last week in class. So in this video I want to talk about different ways we can interpret data. So one of the formulas that you may have seen if you took the prep course before this was the distance formula. And this is the distance between 2 points, or sometimes you hear it referred to as the length of a line segment. And so we're basically looking at what's going on between a coordinate at x1, y1 and a coordinate at x2, y2. And it has this pretty intense formula here. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. It can seem pretty daunting, but if you think about where it comes from, it's not so bad. So where does this formula come from? It comes from the Pythagorean theorem. So I want you just to look at this picture, and don't look at this quite yet. Imagine that I just had a coordinate here at x1, y1, and a coordinate at x2, y2, and I connected them with a line segment. And I wanted to know this distance. The problem is it's a diagonal line, so I can't really count it. I suppose if I got a ruler and I measured the distance here and used a ruler, I could estimate it that way, but that's also not a very algebraic approach to figuring out this problem. So instead, I want you to imagine that I just drew a horizontal line between x1 and x2 and a vertical line between y1 and y2. And then just observe what shape that makes. It should make a familiar shape. This familiar shape is a right triangle. And so if you think about the formulas you've memorized in the past, one of the most famous ones, perhaps, is the Pythagorean theorem. So imagine that I called the bottom of this triangle A, and I called the height of this triangle B, and this would be called the hypotenuse because it's across from this right angle C. Maybe you remember this formula? A squared plus B squared equals C squared? Well, this is the formula we're going to use to build up this kind of crazy distance formula here. So I want to look closer at this A. Now, over here in the picture, A is this distance here. And if we wanted to express it, we would have to subtract x1 from x2, larger minus smaller, and we would get this distance. So here I'm substituting A for x2 minus x1, and it's squared because of the Pythagorean theorem. So let's look at this B. This is a vertical line, so I'm going to look at the y values. I'm going to go the bigger y value, y2, minus the smaller y value, y1. So this distance B is equivalent to y2 minus y1. It's squared again because I'm squaring it. The hypotenuse for my distance formula, I'm just replacing with a d because I want to call the hypotenuse distance for this purpose. So if I take the square root of both sides, here's that distance formula from up here. It's just the Pythagorean theorem. So when you're working on the xy plane and you have some nice whole numbers, this isn't so bad, and that's the first example I want to show you here. What do you do when you have a whole number? Well, here we're asked to find the distance between 1, 5 and 4, negative 1. So I drew that over here. Here's the coordinate 1, 5. Here's the coordinate 4, negative 1. Now before we get to the formula, I went ahead and I drew a right triangle. I did a horizontal line and a vertical line. This is what my right triangle looked like. Now we're just going to old school count. I want to count this distance. It's 1 block, 2 blocks, 3 blocks. So the length of the base of this triangle is 3. Then I'm going to count the blocks of the height. So 1 block, 2 block, 3, 4, 5, 6. The height is 6. And I'm counting positive numbers even though this goes into the negative part of the x-axis because I just want the positive length. 1, 2, 3, 4, 5, 6. Now if you're lucky enough to get whole numbers, you might be able to avoid the distance formula altogether because if you have whole numbers, you could use this option. You could plug in the base, the height, and find the hypotenuse. So 3 squared plus 6 squared is c squared. 9 plus 36 is 45, and the square root of 45. We do have to reduce our square roots in college algebra, so what you want to think about is, are there any factors, two numbers, that when you multiply them give you 45, one of which is a perfect square? And so you might think 9 times 5. Now the reason I'm breaking this up into 9 times 5 is then I can reduce this radical. The square root of 9 is 3. Notice I took it out of the square root sign, and I left 5 in. This is a reduced radical, 3 square root of 5. I'm not really interested in decimals, so don't give me any decimals. Give me a reduced radical, an exact answer. Now, what you really probably should do, though, is practice the formula, right? Because we're not always going to have whole numbers. In fact, the next example we won't. So here's the formula. Over here I've organized my points. My first point was 1, 5, and my second point was 4, negative 1. So this is my x1, my x2, my y1, and my y2. So into the formula goes x2 minus x1 squared, y2 minus y1 squared. I get a 3 squared and a negative 6 squared. Remember, when you square a negative, it becomes positive. So there's my 9 plus 36 again. Distance is the square root of 45. Same reduction as up here. I get 3 square root of 5 for that distance. In the next video, we're going to look at what we can do with this formula when we're talking about fractions.